Okay, before I give you the next example, I need to kind of show you something. Earlier in chapter 4, I said find the zeros of this. What did you do? A few things you did. One, you should try to factor it first. If we tried to factor that, it would be x minus 6 and x plus 1, right? Since we're finding the zeros, I set that equal to 0. Now, how do you find the zeros? You set this this is a factor, right? It's a factor. You set this factor equal to 0. So x minus 6 could equal 0. Or you set this factor equal to 0. X plus 1 could equal 0, right? And then you solve. X equals, move 6, and x equals 6. Or x could equal, move that over, negative 1, right? And you just solved, you just found the zeros of this function. Now what we're going to do is we're going to go backwards. Here's what I'm going to do. I'm going to say x equals 6, so x equals 6 is a 0. Okay? I want you to come up with the factor. If x equals 6 is a 0, then x minus 6 was a factor. You see that? X minus 6 is a factor. If I said x equals negative 1 is a 0, then what was the factor? Well, look. X plus 1 was a factor of this. What do you mean by factor? Okay, factors of 10 are 5 times 2. Those are factors. Factors of this is this times this, right? So this has to be a factor of x squared minus 5x minus 6. If this is a 0, this has to be a factor of the original, okay? So this is what I want you to get out of this. If, I'm going to rewrite, let me do this. If r, instead of saying if 6 is a 0, if r is a 0, right? If r, any number could go here, then x minus r is a factor. This is very, very important. Star this idea. But understand it. If r is a 0, then x minus that number is a factor, right? If this is a 0, then x minus that is a factor. Look, it's right here, x plus 1. Okay? So let's move on to the next type of example. Next one, we're going to factor polynomials. We're going to take this and we're going to factor it. But what they do is they tell you one of the factors is x plus 2. It's kind of like this, okay? Let me break it down easier for you. If I told you factor 255, and you're like, I don't know. But what if I told you so factor 255 if 5 is, I told you 5 is a factor of this, which means 5 times something gives me 255. So what would you do with this and this? What would you do? You would take 255 divided by 5 and then get an answer. Okay, 51. Now you factor 51 if you could. Okay, so 5 and 51 are factors. Okay, so this is the same idea. What if I said factor this? If I tell you that x plus 2 is a factor, all you have to do is take this divided by x plus 2. And then you'll see something. And then if you can, factor that more and more. Alright? So here we go. How would you divide this divided by x plus 2? If it were me, I'd use synthetic if I could. Alright? So what goes in the box? And what goes here? Well, what goes in here is 3x cubed, negative 4x squared, don't write x squared, negative 28 x's, and then negative 16. There's nothing missing up here, so no zeros. In the box, what goes in the box? It's supposed to be x minus r. R is not 2. R is actually negative 2 goes in the box. Okay, and that's the thing that people miss the most. Bring down 3, multiply, negative 6, add, negative 10, multiply, 20, add, negative 8, multiply these two, 16, and notice something, negative 16 plus 16, 0. What does this mean? What if I get a remainder of 0? That means negative 2 is so that means one thing. Negative 2 is a 0 of this function right here. If I get a remainder of 0, negative 2 is a 0. If negative 2 is a 0, that's what I said on the last little part before I got to this example, then x minus r, there's my r, x minus r is a, so x plus 2 is a factor. The only way you can tell if something's a factor or not is if you get 0 right here. But we should, because they already told us x plus 2 is a factor. So if you don't get 0 here, you did something wrong. Okay? So look what's left over though. What does this actually mean? 3, negative 10, and 8. That means 3x to the what power? Well, this was x cubed, so take it 1 down. 3x squared. Then just go in order. Minus 10 x's, and then minus 8. And that is the other factor. So there's two factors so far. They told you this was a factor, and now this is a factor. So basically this times this is the original. Now we want to see if we can factor more. If we can, most likely yes. I'm not going to make this be done. Okay, so how do you factor 3x squared minus 10x minus 8? Well, it's a quadratic, right? You know how to factor quadratics. I would do slide and divide or do the other way. So 3x squared minus 10x minus 8, slide and divide, slide it down. X squared minus 10x minus 24. Factors of negative 24 to add up to negative 10. Not 6 and 4, I wouldn't work, but 2 and 12. So yeah, x minus 12, x plus 2. And then I have to divide by the a, so divide by 3, divide by 3. Next step, simplify. 12 thirds is x minus 4. And then simplify this, it's done. So therefore I move the denominators back out to the front. So x minus 4 and 3x plus 2 are my factors of this thing, right? So here's all my factors. These two are factors of this. And then this is the other factor. So factor completely is technically this, this, and the one they told me in the beginning is x plus 2. These three, if you multiplied x times 3x times x, that would give you 3x to the third. 4 times 2 times 2 will give you the 16. And I mean, that's not all you need to do, but that gives me a quick check. Like, would I get the original? Probably. If that works, probably. So this right here is completely factored, this thing. Okay? It's kind of like 255 completely factored is 5 times 51, and then if that broke down you would write a different one. I think that's prime though. Okay? So, there we go. Done with